The equation of the line L1 is 2y minus 6x plus 3 equal to 0. The line L2 is parallel to L1 and passes through the point 211. Find the equation of L2. Well, as L2 is parallel to L1, therefore it must have the same gradient as L1. Therefore, my first step is to find the gradient of L1. To find the gradient, the equation in line must be the form y equals mx plus c. As the equation in line L1 is not currently of the form y equals mx plus c, therefore my first step is to rearrange it. As I want my equation to start positive y, well here I've got positive 2y on the left hand side. So I'm going to leave the positive 2y alone on the left hand side. And I'm going to move the negative 6x and the 3 to the right hand side by doing the opposite. So the opposite of minus 6x, moving it to the right hand side, therefore will become positive 6x. And the opposite of plus 3, moving it to the right hand side, it's going to change sign. It's going to become negative 3. As that's 2y, and I want my equation to start positive y, I know the opposite of times by 2, therefore is divide both sides of my equation by 2. I know on the left-hand side, 2 over 2 will cancel to leave us with single y. On the right-hand side, 6x divided by 2, well 6 divided by 2 is 3, so 6x divided by 2 will give us 3x. And negative 3 over 2, I can write as a decimal as negative 1.5. As I'm told the line L2 is parallel to L1, therefore it's going to have the same gradient as L1. Well, the gradient of L1, now it's the correct form, the gradient is 3. And as L2 is parallel, it has the same gradient. So now the equation of L2 is going to start y equals, for m, I know the gradient's going to be the same. So it's going to be y equals 3 lots of x, and I've still got plus c on the end. To find my value of c, I also know that the line L2 passes through the point 211. So 211 is a coordinate, i.e. x, comma y. And that point must satisfy my equation y equals 3x plus c. So substituting, every time I see y, I'm going to substitute y to be 11. So on the left-hand side, I've got 11 equals, on the right-hand side, 3x in algebra means 3 multiplied by x. In this case, when x is 2, so here I'm going to have 3 multiplied by 2. And I've still got plus c, which is what I'm trying to find. Leaving the 11 on the left-hand side alone, well, 3 times 2 will give us 6, and I've still got plus c. As I want to get the value of c by itself, I know the opposite add 6, therefore is to move it to the left-hand side. Opposite add 6, therefore is subtract 6 on both sides. On the right-hand side, I know 6 take away 6 will cancel. That'll leave us with simply c. And on the left-hand side, 11 take away 6 gives us 5. So now I know c is equal to 5. Therefore, the equation of L2, it's going to start y equals 3 lots of x. And the value of c, in this case, is positive 5. I'm now given that the line L3 is perpendicular to L1 and passes through the point 211. And we're asked to find the equation of L3. Well, if L3 is perpendicular to L1, therefore the gradient of L3 is the negative reciprocal, i.e. minus 1 over m of the gradient of L1. As I already know the gradient of L1 from earlier, we know the gradient was 3. Hence, the gradient of L3 is going to be negative a third. And again, substituting to our equation of line, y equals mx plus c. Therefore, I'm going to have y equals, m is my perpendicular gradient, which is negative reciprocal, i.e. minus 1 over m. Hence, minus 1 over 3, minus a third. And obviously, it's lots of x, and again, plus c. As I know L3 also passes through the point 211, I know that point must satisfy this line. As I've got a coordinate, I know a coordinate is always x, comma y. Therefore, when x is 2, y is 11. Substituting into my line. So y, I'm going to substitute for 11. So on the left-hand side, y, I'm going to substitute now to be 11. So 11 is equal to negative a third, lots of x. So it's going to be negative a third multiplied by x. In this case, x is positive 2. And I've still got plus c. Leaving 11 alone on the left-hand side, I know negative a third times 2 will give us negative 2/3. And I've still got plus c. As I want to get the value of c by itself, I know the opposite of minus 2/3, therefore is to add 2/3 to both sides of my equation. On the right-hand side, I know negative 2/3 add 2/3 will cancel to leave us with just simply c. And on the left-hand side, 11 add 2/3 is simply 11 and 2/3. Hence, the equation of line L3, therefore, is going to be y equals negative a third x plus 11 and 2/3.